I published this circuit a few days ago and I wanted to get more energy out, more audio power out. So I decided to use other N transistors and well, had to do some adaptations to the circuit to get approximately, say, 3 watt or 4 watt out. And this is the definite circuit of that amplifier. Made with a 741. I also used the TL071 CP and the sound was somewhat more clear, not so rich compared to the 741, but anyway, in this circuit you can replace the 741 by a TL071. Pin connections of the 741 and transistors, the music that I play in this video. And the adaptations that I made were this. I made a kind of low filter at pin 3, from pin 3 to ground, made with 2 capacitors. And I made a high filter, and then I mean that the high is pushed up with the help of this 10 nanofarad ceramic capacitor. It must be ceramic, otherwise there's no effect. I want to demonstrate that later. And furthermore, the whole circuit is more or less identical compared to the earlier circuit. The 2N3055 and the 2955 must be mounted on a so-called endless heatsink, and in this case this is endless. Such a big aluminum plate is more or less an endless circuit, an endless heatsink where the transistor can get rid of all the heat that is developed in the junction inside the transistor, and here the same for the 2955. I've tested the circuit thoroughly, few hours, with an overvoltage at 4 kHz, and I used a resistor for that purpose. That resistor got very hot, and also the transistors got hot, but there was no thermal runaway, and I'm almost sure, more or less absolutely sure, that when you use a big heatsink there will be no thermal runaway at all. I've also heated up the diodes, these 2 diodes here in the middle of the screen, heated up with the soldering iron, and also that gave no effect at all. Not more current or less current or whatever. So that, my opinion is that you can mount them on your circuit board. Don't have to glue them to the heatsink. That's often done to stabilize an end amplifier. Furthermore, there's not so much more to tell. I'm gonna switch to another music and let's listen to the sound. So I think it's a quite good sound. Maximum volume. That bass doesn't sound properly, and of course because I'm now overdriving the circuit with signal. And also my loudspeaker boxes, especially this one, was not made for typical low frequencies, say 50 Hz or so, the low audio band. But it functions quite good. and the supply voltage is between 33 and 34 volts. In the kind of destruction mode it takes 300 milliampere, and for normal use between 100 and 150 milliampere. And you can see that here on the meter, almost not current, but of course I have to and the circuit works now on 36 volt. The filters are here. I want to demonstrate that when I can find the crocodile clip. The low filter is now connected and the sound gets dull. And now I will try to connect the 10K, that's here, at pin 2, and perhaps in the second part of the music you will hear the difference. It has more high well, it's the same music. Yes. In Albany, New York. This is the dull sound, and here even more. So I hope this was more or less clear. Anyway, it works very good. Always use the fuse in the power supply lead. It was not drawn in the schematic, but anyway. Bend over somewhat. This resistor here proved to be quite critical. When you do a study of the circuit on the oscilloscope, you will see a slight distortion, and I couldn't get that away. Very tiny distortion in the sine wave. I did my best, but anyway the sound is quite pleasant. And it works good. The only disadvantage is, in my opinion, that the power supply, the supply voltage is quite high. So I'm gonna try to make other circuits for lower supply voltages. I've got new information, very important new information about audio amplifiers. I want to use that to make an amplifier that works on a lower supply voltage and of course has a good sound.